All right. So, moving our stuff. We have 2-6 was where we were kind of continuing again. And I just wanted to do a bunch of examples today. Nothing new. I figured there's such an odd change that happened initially. I don't want to introduce anything new today. So let's just do some. So let me move this box. There you go. All right. So in September, the
I
cost of
do have
gasoline.
one more question.
Yes, of course.
I did start the homework,
Okay.
and on one question, I didn't realize it said round to the nearest tenth.
Hmm?
So I
Oh,
got it wrong, but I did the answer correctly.
oh, that's
Like I
annoying.
just rounded to the nearest hundredths instead of tenth.
Yeah.
I commented on it, mailed
Okay.
you, but
I'll make a note. Check. Usually that won't matter in the grand scheme of things. I think I remember last semester there were a couple problems like that, and I went back and changed them at the end, and it didn't like that point didn't really impact. But I'll make a note of it. Check grade rounding. All right. So cool. I know that's what I hate about that online, the grading. It can't differentiate really. It's very strict, kind of because it's a computer, but makes doing homework online much easier, or over Zoom much easier. Let's see. So the cost of gas in Berlin was around $1 and well, like, I don't know if it's €1 and 23 cents per liter. All right. And I think we ended class with one like this Thursday, and Thursday seems like an infinity ago. What would the equivalent cost be in US dollars per gallon? So we're going from euros per liter to dollars per gallon. And I give you the conversions here. These change. This one, the dollars and euros changes every time. So if you look at some conversion charts, it might be different, but it's all the same. So let me write out what we have. And remember, the important thing is the word per. The word per means that you have a fraction, that you have $1.23, and when you read per, you should say over liter. And if there's nothing written there, it's usually implied that there's 1 liter. So you can write $1, like €1, sorry, 23 euro cents per 1 liter. All right. And now we just need to convert, as we did last week. You want to convert each unit independently, essentially. And so we're going to use two conversion factors. And I already give you what the conversions are strictly. So I'll do the euro first, and then I'll do the liter. Right. So to get rid of the euro and convert it into USD, you put the euro unit in the bottom because I want that to cancel. So I'll put a euro down here, and I'll put USD up here. USD is United States dollar. So that will work out because the euro will cancel and I'll get USD. And then if I can even put this one in, so I'll put the liter here because I want the liter to cancel and I want it to be in gallons. So I'll put gallons down here. And you'll note now that the liters cancel and my units, when I plug in my numbers, will be USD or United States dollars per gallon, which is exactly what I want. All right. And now you just plug in the numbers. So I give you all those. So I say $1 equals 0.85 euro. So put the 1 there, the 0.85 down here. And then for the liter, you do the same thing. I have 1 gallon equals 3.785, whatever, liters. So the 1 goes with the gallons. I don't know what my dog is barking about. And the liters goes up here, 3.785. And now you just compute across. So, pardon my mute. My calculator. And remember, when you're multiplying fractions like this, you just multiply across the top and multiply across the bottom on their own. So you have 1.23 times 1, doesn't do anything, 3.785. There we go. And then on the bottom, I just have the 0.85. Everything else is a 1. And the units again are USD per gallon. So you can write that as USD per gallon, or you can write it as dollar signs per gallon. Right, and that's just calculator work at this point, right? So I can do what's happening? Oh, all right. My computer tried to quit Zoom. If Zoom shuts off, that's why. Oh, and the light's not on, is it? Just a second. It is. All right. I don't know why it's so dark today. So I have 1.23 times, and then it's 3.785, and then divided by 0.85. So I get about, I don't know, you could round it to 550. I'll say 548 maybe. Right. So this is equal to 5.48, and I'll do dollars per gallon. So it's pretty expensive. And I think that's relatively accurate, actually. If you go to Europe, it costs a lot of money for some reason. Taxes? I don't know. To buy gas. So, yeah. Questions there? Again, we did one like this last week, but I just wanted to review how we did these. All right. So let's move on. So this is one from the homework, and this is actually kind of new. I don't think we've done one like this before quite. But it's interesting. So let's see. So you read online that a 15 by 20 foot brick patio would cost about $2,275 to have professionally installed, which seems really cheap actually. Estimate the cost of having a 14 by 19 brick patio installed. And so what they want you to do, and what they're not really telling you to do, but they're implicitly assuming you are going to do, is you want to assume, or you want to compute, sorry, you want to compute the cost per square foot. And once you compute the cost per square foot, you can find how many square feet are in a 14 by 19 brick patio and kind of go from there. All right, so that's what we want to do. So you want to find cost per square foot. And remember, when we did areas and volumes, we talked about square units, right? When we talked about the area of a rectangle, the units were like inches squared or feet squared or something like that. So that's what the square foot means. Again, it's the units of like an area or something like like a deck or a patio. So what I'm going to do is, so it costs $2,275 for a 15 by 20. So I'm going to compute the area of that brick patio. And the assumption here is that it's rectangular. They give you the dimensions of it. So it'd be weird if it wasn't. So the area of 15 foot by 20 foot patio is, and so you just find the area by multiplying them together, right? Because it's kind of assumed to be a rectangle. It's not really said it's a rectangular patio, and so strictly speaking, you probably would want to include that. But again, it'd be really weird if it wasn't. So area is, you just multiply them. So it's 15 times 20, and then we can plug this in our calculator. Feet squared. So let's see. Oops. 15 times 20. I don't know what's happening out there. 300 square feet. 300 feet squared. And this is another way to write it, of course. The alternative method, or the alternative way you might have seen, is square feet. If either of those notation are acceptable, so whatever you're comfortable with. This one is more common, especially because I think some of the problems, we might do a couple, involve cubes, like volume. If you're doing things with volume, then it's feet cubed in similar units. But anyway, so that's our area. And what I'm going to do is I'm going to take the total cost and just divide it by the area. And that will give me the cost per square foot. So the cost per square foot is then, and I should note, the way we're computing this is encoded in cost per square foot, right? Because remember, the word per means you're putting something over something else. So you're taking the cost per, you're putting it over the square foot on the bottom. So that's all we're doing to compute it. So I take the total cost, 2,275, and I'm dividing it by 300 square feet. And what do I get? You just plug that in your calculator. Let's see, there we go. So 2,275 divided by 300. You get about 7.6. So again, you can round whatever you like, but it's 7.6. It's dollars per square foot. All right. So any questions how you've been doing this so far? Right. And now that we know the cost per square foot, I can go back up here. And the question was, estimate the cost of having a 14 by 19 brick patio installed. So since I know the cost per square foot, I can just multiply that times the area of a 14 by 19 patio. So the area of 14 foot by 19 foot patio is, and just like before, you just multiply the dimensions together because it's assumed to be rectangular. If it wasn't, it'd be weird. So it's 14 times 19 feet squared. And that ends up being 14 times 19, 266. 266 squared feet. And so if it costs $7.60 per square foot, and I want to cover 266 square feet, I can just multiply those numbers together to get my answer. So, the cost will be, so it's 760, again, the cost per square foot. So every square foot you build will cost that much. So it's 760 times the area, 266. All right. And you know what? I should put units here. Let me get a square sheet of paper. So you can just plug this in your calculator. Let's look at the units before I move on. So let me move off to the side here because the units on this are interesting. So it's $7.6 per 1 square foot, right? So that's what we found. That's the cost per square foot. And then I'm multiplying it. All right, and I should write this the same way I've been doing it, feet squared. And I'm multiplying it by 266 feet squared. And so you'll note that the feet squared cancel, and I just get dollars. And it's kind of what you wanted, right? Because you wanted to estimate the cost. So whenever you're doing these problems, always guarantee that the units are working out. So I get 266 times 7.6, and it's costly, right? So this is equal to $2021.6. All right. So assuming it costs the same per square foot as it does for the 14 by 20 foot patio, it should cost around $2,021.60. All right. So it's kind of cool. Again, in a real life kind of situation, this might be different because you have to take into consideration maybe the 15 by 21 has more features in it. Maybe there's certain corners or like decorations that aren't in the other one. So it's kind of, we are assuming, oh, it's okay, Gary. We are assuming that that it's uniform. So the cost per square foot is the same. Or I guess you could consider it an average even. But you know, if you're doing this in real life, there are more considerations. Any questions about that example? And again, I think this was on the homework. So, great. Sounds good. And yeah, here's another one that's, again, this is on the homework. Your numbers might be different, but the overall problem should be comparable. And this one is a similar kind of idea. So this one's about a hose. And so it takes a hose 2 minutes. So I keep moving it. It takes a hose 2 minutes to fill a rectangular aquarium. So this one actually tells you it's rectangular aquarium, 8 inches long, 12 inches wide, and 14 inches tall. So if you think back to the geometry stuff we did in chapter chapters in this book, it used to be 10, chapter whatever. Remember, it's like a rectangular prism. So it's like a big box. It's an aquarium. And they give you the 3 dimensions. And so we know how to find the volume of that. We just multiply those dimensions together. How long will it take the same hose to fill an aquarium measuring 25 by 26 by 32? So it's the same kind of question. What we want to find is the rate at which the hose is filling these things, these aquariums. And the way we're going to do that is we're going to do, I don't know, square cubic inches per minute. So you're going to find how many minutes it takes to fill 1 cubic inch. And then once you know that, you can kind of scale it to this different tank, right? So let's see how that works in general. So So the volume of this first aquarium, 8 by 2 by 14. First aquarium is, so we just multiply them together, right? I get 8 inches times 12 inches times 14 inches. And I don't know what that is. So you use a calculator. So I get over here. Beautiful. 8 times 12 times 14. So I got 1,344 cubic inches. 1,344 inches cubed. All right. Because in this case, we're talking about the volume, how much space the aquarium takes up. And now we know that. It takes 2 minutes to fill this aquarium, which seems like not a long time. But we can now find how long it takes to fill just 1 cubic inch, and we'll scale it. So it takes, the, I don't want to say it, the cubic inches per minute filled by the tank, or the hose, sorry, is, my tooth hurts, I don't know what's happening. So the cubic inches per minute, and this is what we're finding again, cubic inches per minute, not that part. And remember the word per, it means inches, cubic inches over minutes. So I'm gonna take the volume, 1,344 inches cubed, and I'm gonna put it over how long it takes, 2 minutes. And you can plug this in your calculator if you'd like a nice explicit answer. So I get 1,344 divided by 2, 672. So my hose fills 672 cubic inches per minute. All right. And so basically that's telling you like the flow rate of the hose, like how much water is coming out of this hose, how fast it's coming out too. And now once we know this number, we can just scale it. So my second aquarium here is 25 by 27 by 32. So it's quite a bit larger. It's like twice as large, just give or take. And so what we can do is we can find the volume of the second tank and then just multiply it by this number. Can I just divide it? Minutes. I guess we'll see how the units work out. We might end up dividing it. It's okay. We'll see. All right. So the volume of second tank is, so I got you multiply them together like we did before. So 25 inches times, what is it, 27 inches times 32 inches. And use your calculator. So I have 25 times 27 times 32. I hard to see. I know my light in this room is not very good. So it's 21,600. So it's huge, right? 21,600 inches cubed. All right. Any questions so far? All right. So we're kind of doing this in a similar way, right? That we did the previous one, but now everything is volume. All right. So now here's the thing. I have some volume and I want my answer to be in minutes. And so the one thing you can do that's really useful with the units is you can kind of fumble with them to make it work. So what I mean is I'll get another sheet of paper. So I have this much cubic inches. So I'll write that down. So 20,600 inches cubed. And what you'll notice is if I kind of proceed like I did in the previous one, if I just multiply this number by that number, my units won't work out, right? Because this is inches cubed over minutes. And so the resulting unit would be inches to the sixth over minutes. It's very odd. And I just want minutes. But what I can do is I can take this number and just kind of flip it, because what this is saying is that the hose is filling the aquarium 672 cubic inches per 1 minute. And so what I can do is I can multiply this then. I can put inches cubed in the bottom, minutes in the top, kind of like I was just doing a unit conversion, and I'll put the 672 with the inches cubed and the 1 with the minute. And now when I cancel my inches cubed, I get minutes. right? And so to figure that out, you're just using the units purely as a guide. Like you're just kind of blindly following the units and hoping it works, and it will work. Um, because when I solve this now, it's kind of amazing. When I plug this in my calculator, I divide 21,600 by 672. I get about 32. 32 minutes. So it takes 2 minutes to fill this kind of small tank. But if you have this huge tank that's 25 inches by 27 by 32, so it's a yard deep, it's 2 feet tall and 2 feet wide, it will take much longer because the first tank, mind you, is a fraction of that size. This one's 20 times as big. So yeah, it takes a lot longer. Right. Any questions? So this one was a little more difficult, I would say, just because you first have to find the volume of this first tank. You then have to find, and you could have done this the other way. You could have done it minutes per cubic inch, just flipped it, and then you could have multiplied it like we did in the previous problem. But this one, I feel like this unit makes more sense to me because if you think about it, you're filling this many cubic inches per minute. But I guess the other unit makes sense too. If you did it the other way, for instance, what I mean is if you had computed 2 minutes, 2 minutes over 1344 inches, 1344 inches cubed. If you had done it this way instead and computed this number, when you do that, for instance, you get, what do you get? You get 2 divided by 1344. Oh, it's tiny, 0.0015. 0.0015. This is minutes per cubic inch. So if you did it this way, you could have done the same thing, and then you would take this number and multiply that by 21,600. What this represents is the amount of minutes it takes to fill 1 cubic inch. So there's a couple ways to do these problems, assuming you interpret the way you're doing them correctly, right? So, and then again, if you take this number and multiply by 21,600, you also should get about 32. But the same answer, it's just different ways of getting there. This way you're doing minutes per cubic inch. The way that I thought might be more natural is cubic inch per minute, but both of the same kind of mechanism. Right. Any questions?
Yeah, actually I do.
Yeah.
I can't believe I'm going to ask this question because I know it's going to open a can of worms. But some of these figures would also be influenced with water pressure.
Oh, I know.
No, I just thought I'd bring it up for some reason. I don't even know I don't know if we're going to need it on a test or.
Get out, Gary. No, no, there's definitely a lot of factors. And so I think I mentioned it in the previous one with the patio, like even a patio, you're going to have different factors that influence the price besides just square foot. So it's like number of features, that kind of thing. Same with this problem. There's a lot more things that impact your answer besides just the number of minutes it takes to fill the hose. Maybe you have more faucets on and you're on a well and your faucet starts running really low, but yeah, you're totally right. Yeah,
I just had to say something. I just realized, or I just watched a TV show from back in the 80s, from the it was a Back to the Future cartoon. I got season 1, but there's a quick experiment you can do. Take a pop bottle, put 3 holes in it, spaced, and then cover it with tape. Fill up the bottle, and then remove the tape, and you can watch the air or water pressure from each hole.
it's kind of cool.
Yeah, I just that's why I was looking at this, and I'm like, okay, then there's water pressure. I didn't know if you're going to get into water pressure next.
No. That's more of a physics kind of thing. Yeah, I don't know where that comes in, but not here. We work with like spherical chickens, right?
I see.
Yeah, everything's perfect. Yeah, I don't even know anything about water pressure, so it doesn't work out. Any other questions? Awesome. All right. So yeah, so I thought those two were kind of tricky in the homework. So on your homework, try to use that as a guide, and your numbers will be different, obviously. But all right, this one is kind of similar to how we did the one with the water volume, actually. It's a different problem, obviously, but the methods feels the same. So a bicycle is traveling at, again, be careful when you read it, 60 miles per hour. So again, the word per there should jump out at you and say, oh, I have a fraction, I have a rate somewhere. So when you read that, you can always rewrite it. You can say 16 miles and then per, and there's no one there, but it's implied per, so it's 1 hour. So that's what this is. This is how, this same thing, but just written differently. How many feet will he cover in 45 seconds? And then round to whatever, I don't care. So I know that he's going 16 miles per 1 hour. And I want to know how many feet he'll cover in 45 seconds. So I have two kind of things happening here, right? I have seconds, but my rate is in hours, and I want feet, my rate is in miles. So the first thing you want to do is convert this miles per hour into feet per second, just to get it compatible with what the question's asking you for. If they were asking you for how many miles will he go in 10 hours, you wouldn't have to do anything because it would already be in those units. But since it's not, we're going to convert it, all right? So I'm going to start by converting those. So I'm going to do miles to feet, and then hours to minutes to seconds. Like we did this last week too. So hopefully this is just a review. Only two dashes. It's kind of like, what is it? Two dots and a dash. It's like that old World War II drink. Anyway, so miles in the bottom, and I want it in feet. So feet will go in the top. And then I want hours, and you can do these all by one. I'll do them one by one this time. So there's 1 mile and 5,280 feet. So then the miles cancel, and now I'm in feet per hours. And now I want to make it into seconds, as I said, because it's asking you for something about seconds. So you want to kind of make it all compatible. So I convert it into seconds. Either you know how many seconds are in an hour, which would be fine. It's just 60 squared. Or you can go minutes to seconds, which is a little cleaner. So I'll do it that way. So I'll put hours up here, go into minutes. So I'll put minutes in the bottom. And then you just have to ask yourself how many minutes in a second. And 60. Or sorry, minutes in an hour, and it's 60. So I have 60 minutes, 1 hour. And of course the hours cancel. And now I'm in feet per minute, but as I said, I want feet per second. So I just need to get rid of these minutes and convert them to seconds. So minutes go up here, seconds go down there. And again, same question, how many seconds in a minute? And hopefully you should say 60. And now we're good because the minutes finally cancel. All right, so now we have our rate in the appropriate units that are compatible with the questions asking. So if I compute this out, which I do want to do, so let me get my calculator here. So again, you multiply across the top. I have 16 times that ugly 5,280. So 16 times 5,280. I get that ugly number. And then I'm dividing it by one. Those don't do anything. And then I'm dividing it by 60 and 60. So I'll divide it by 60 times 60. And when you're doing divisions on your calculator, make sure you divide it. Make sure you're doing it carefully. So you'll note I did the answer, so that 84,000 number, divided, and I put parentheses around the 60s when I multiplied them. If you didn't put parentheses, I'm not exactly sure. I think it would still work. It might depend on your calculator, but so when in doubt, always put parentheses. Anyway, you get about 23 and a half. So maybe I'll round better today. I'll do 23.47, right? And as I said, it's feet per second. All right, so that's his speed in feet per second. So if I want to know how many feet he will cover in 45 seconds, so I'll first write down I have 45 seconds. And the way you can think about it is you really want to convert the seconds to feet. And what you're using to convert them is his speed. That's it. So it's just another unit conversion, but it's not like how many pounds in an ounce or how many ounces in a pound. It's how fast is he going or how far is he going based on his speed. So his speed is just telling you, this is saying, and this says he's going 23.47 feet every 1 second. So in 45 seconds, you just multiply them together. And you can see that in the units as well. So 45 seconds. And then if I put 23.47 feet in the top and 1 second in the bottom, you'll note that the seconds cancel. Also, I think the abbreviation for second is just an S, not SEC. I don't know why I do that. In any case, though, I just get feet, and that's my answer. So I'll do, there we go. Can you see that? There we go. 45 times 23.47. So he goes about 1,500 or 1,056.15 feet in 45 seconds. Right. So that's how you can think about these. A lot of these unit conversions, you're using their speed is just a way to convert between different units that really intrinsically have nothing to do with each other, but in the context of a bicyclist, their speed relates the two together. Right. Cool. Any issues there? All right. So again, this was on your homework too. It's a little different, so I thought I'd cover it. Let's do this one. This one's fun, I think. It looks cool. Again, it kind of relates to physics. All right, so this one says sound travels at 750 miles per hour. If you stand in a canyon and sound a horn, you will hear an echo. So the first part, suppose it takes about 2 seconds to hear the echo. How far away is the canyon wall in feet? And just like the other problems we did with the patio and the hose, we're gonna kind of make some assumptions. Like, obviously sound travels differently through different materials and different air and stuff like that. If it's warm in one part of the canyon, colder in the other, it might make the air travel different speeds, but we're gonna ignore all that and just say it travels at the same speed everywhere. But it's definitely interesting in any case. But yeah, so it travels at 750 miles per hour. How far is the canyon wall in feet? So if you think about it, it's kind of like the same, question as a bicycle question, right? They're giving us a time, and the other one was 45 seconds. This one's 2 seconds. And they're asking you how far away is something. Like the problem we just did was how far did the bicycle go? Here, it's how far did the sound travel to the canyon wall? So it's gonna be the same setup essentially. We need to convert this miles per hour into feet per second. And then once we have that, we can find how far it goes. All right, so let's try it. But again, it's just really worded oddly, so I figured I'd go over it because I don't know, it's kind of weird looking when you first see it. So I'll start with converting miles per hour into feet per second. And if you want, you can even go back and just use the same conversion factor we did. So I have 750 miles per 1 hour. That's what the per means, right? It just means over 1, whatever the unit. And then I'll do 1 mile, 5,280 feet. And then I'll convert it into minutes and seconds, or maybe I'll just do seconds this time. Why not? I'll do that. So I have 1 hour, 3,600 seconds. I'll keep using SEC because it's too late to change. And so my hours cancel, my miles cancel, and we just need to compute that. Let's see what it is. It should be pretty big, I'm guessing. I'm not sure. 750 times 5,280. It's a huge number. And you divide it by 3,600. So that's beautiful. 1,100. So the sound is traveling at 1,100 feet per second. So it's going really fast. I guess it's sound, right? And so the question is, if it takes 2 seconds to hear the echo, and we'll see. So let me draw a picture up here. So like you're here. This didn't occur to me until just now. And this is the canyon wall. Right, so you have a horn. There's your horn. And so you sound a horn, you hear an echo. So basically the sound travels here, right? It hits the canyon wall and it travels back. So the one thing to note is that however far it travels in 2 seconds is this round trip distance, right?
Okay, this
Yeah,
is a stupid question, but ours is feet per second. And it takes 2 seconds, so it would take a second to get there and a second back. So wouldn't that be our answer? Just
yeah,
double?
yeah, exactly. It's just double. Yeah, so whatever answer we get here, we'll have to take half of to get the distance to the canyon wall. So like, let me find it and I'll tell you more. So like, so the sound's traveling 1,100 feet per second, and it takes 2 seconds. So let's see how far the sound traveled in that time, right? So I have 1,100 feet per second. I can just multiply it by 2 seconds to convert it into feet. And so the seconds cancel, and then I just get 2,200 feet. So it travels 2,200 feet between you sounding the horn and it hitting the wall, echoing, and bouncing back. So the wall should be exactly half this distance, if that makes sense, right? Because it goes there once and it must come back. So it looks like it's 1,100 feet. So wall is 1,100 feet away. At least that's my reading of the question. um, does that make
But we
sense?
didn't even have to do that though because we kind of already had it. That's feet per second. It takes 2 seconds. We would double that.
Oh, you're
So it would
right.
come back.
Yeah,
So we already found it out. We just get rid of the seconds.
yeah. That's a quick way to get there. Now, if it was 3 seconds, you'd have to triple it and then half it. But since it's 2 seconds, it's the same. But you're definitely right. Any other questions there? So it's kind of tricky, this question. It didn't occur to me initially about the echoing. It just occurred to me when I was reading it. So yeah, that should be it though. That's neat. All right, let's try the second part. Suppose you stand 1,600 feet from the canyon wall. So maybe you draw a picture because it's fun to draw pictures. I'll put them over here. So this is 1,650 feet. And sound the horn. How long will it take to hear the echo? So you can do this a couple ways, right? You can first just find how long it takes for the sound to go from you to the canyon wall and just double that. Or you can find how long it takes for the sound to go from here and back. So just twice this distance. I'll do it for this 1,650 and just double it. So I'll do that. So boop, right? So for it to go 1,650 feet, I want to see how long it takes. And I know it's going at 1,100 feet per second. So again, what you can think about these rates and everything is you want to just use the units to your advantage. So I want it to be in seconds because I want how long it will take. So I put feet down here, seconds up here, and that makes the feet cancel. So my answer will be what I want. And it always works out when you do that. And so I have 1,100 feet over 1 second. So I put 1,100 with the feet, the 1 second with, or the one with the second, and you multiply through. So in this case, I get 1,650. Oops, there we go. 1,650 divided by 1,100. I get 1.5. And the only thing left is seconds. Oh, sorry, you can't see that. There you go. The only thing left is seconds as far as the units go. So I get 1.5 seconds. So if my calculations are correct, they should be. It takes 1.5 seconds between you sounding the horn and the sound getting to the wall. And so it's asking how long will it take to hear the echo. And so for that to happen, it has to go hit the wall and then bounce back to you.
So would it be 3 seconds?
Yes, yeah. So for the sound to echo completely, it will take 3 seconds. All right. And so yeah, so again, it's 1.5 seconds to the wall and then 1.5 seconds back from the wall to you. And again, this changes depending on like air temperature and stuff like that. But we're just assuming things are averaged. Not gonna get into details like that. Any questions? All right, so those are the ones I wanted to cover from the homework. Now I just want to do a few, let me just do a couple extra for fun. Let me get some more scrap paper here. All right, let's try this one. So this is just a random example. Not that random, but. So a page has 500 words on it. It's on average. So these ones aren't on the homework, but more practice. Okay. If you read a manuscript, read a page. Read a page in 1 minute and 24 seconds. What is your reading rate? Reading rate in words per minute. All right, so we will say that is A, and then we'll do another one at the end. Yep. So it's kind of cool. You can do more things with rate units than just, again, like pounds to kilograms. You can do a lot of different interesting applications, like the bicycle one you might not have thought of initially as a unit conversion, but it's possible. So here we're assuming on average a page has 500 words on it. Again, these are all averages. If you can read a page in 1 minute and 24 seconds, what is your reading rate in words per minute? So you want to interpret the words per minute again. So when you see per, you should be like, oh, it's a fraction. So I want to put words over a minute. Right? So that's my desired unit computation. Now I just need to figure out how many words per minute I can read, right? So here it's saying I can read a page in 1 minute and 24 seconds. And I told you that a page has about 500 words. So I can read 500 words, that's one page, in 1 minute and 24 seconds. So you have a couple options. You can convert 1 minute, 24 seconds. You convert that to seconds and then convert to minutes. Maybe I'll do that. Or you could just straight ahead convert that into like a decimal minute thing. So you could do this. You could say, oh, well, there's 60 seconds in a minute, right? So I have 24 over 60, which is 0.4, and then plus 1 for the 1 minute. So I have 1.4 minutes. So I can read 500 words in 1.4 minutes. And you could put that down here. And that should also work for you. I think I'm going to do it in the second way, just because it seems cooler. So I'm going to go to seconds here. Put seconds here too. I keep changing my abbreviations. And so 1 minute and 24 seconds is just 84 seconds. Right, so this is equal to 1 minute and 24 seconds. Okay. So this, now we're in words per second, and now I can just convert to minutes. And again, you'll get the same answer if you did it the other way too. So I'll do seconds, minutes. So the seconds cancel. So there's 60 seconds in 1 minute, and you're good. So all in all, I get the 500 times the 60. That's what I get in the top. So 30,000, and then I divide it by 84. So I get, it's something about 357 words per minute. Now let's just see if I do 500 divided by 1.4. Maybe I'll get the same thing. All right. So either way you do that problem, whatever way is more intuitive for you. This way uses the unit conversion more. The other way kind of, it still does, but not as strictly speaking. Any questions with that first part? So again, the word per is, I guess, the point of today's lecture. So now for the second part of this question, maybe I'll call this like A, and I'll call this B. So how long would it take to read a, I don't know, you could say like Harry Potter or something, but read a 367 page book? All right. So this one we can do just as a single string of unit conversions, which is always fun. So what we'll do is I'll start with the 367 pages. And I'll abbreviate it PG. Right? And so I know that you can read at 357 words per minute. Right? And I guess we'll say how long in minutes would it take? So I can read at this 357 words per minute, which seems really fast. And I know that one page, oh, there we go, has 500 words. So what I can do is I can convert my 367 pages into words and then use the rate that we determined in the earlier part to determine how long it would take. So I want to convert this into words. So I put pages down here, words up here. I know that one page is about 500 words. And so now the pages cancel and we're in words. And now if I want to convert to minutes, I go up here and this says I can read 357 words in 1 minute, which again seems really fast. And so I can use that relationship. So if I want to get rid of the words, put words down here, minutes here. And so if I can read at 357 words per minute, the way you can rewrite this, you can kind of think of it as 357 words equals 1 minute. You know, it's like a lot of these, like, where's my other unit conversion sheet? Like a lot of these sheets, like, you know, sheets like this, you'll have like, you know, different units together, right? You know, like 12 inches equals 1 foot. 1 mile equals 5,280 feet. It's the same kind of idea as this. Like 357 words equals 1 minute in this system where we're talking about how fast you can read. So you can use it in the same way you'd use 12 feet equals 1 inch or 12 inches equals 1 foot. And you can rearrange things just like we would normally. In any case, so I have 357 and 1 on the top. And now the words cancel, and the only unit left is minutes. So I can just go through and compute. So I have 367 times 500 over 357. So let me see, I can't put this all on the same page. There we go, perfect. So 367 times 500 divided by 357. So it takes about, so it's about, say, 514 minutes. So I should note so 514 minutes isn't really a unit. It's not really clear how long that is, right? So maybe we're interested in determining how many hours that is. That's something else we can compute, right? So in hours, we can compute this to hours pretty quickly. 514 minutes. I know there's 60 minutes in an hour. So 60 minutes, 1 hour, the minutes cancel, and now I'm in hours. And so what do I get? I just get, so it's about 8.6 hours. So that's how long it would take you at this rate to read a book like that, of that length. I don't know how realistic that is. I don't know how fast I read or how fast people normally read. I feel like I don't read that fast. But I guess if it's like Harry Potter or something, it's a quick read. If it's something more technical, it might be longer. Like a math book, it might take a long time. Your words per minute might be like in the double digits. Any questions to that one?
I don't have any questions, but I'm getting hollered at. I gotta go.
Oh, yeah, no worries. Have fun. Have a nice dinner. I'm sorry.
Thank you. If I have any questions on the homework, I'll email you.
Yeah, we can even Zoom over the weekend if you need to or something. So just let me know. Jump. All right. We'll just do one more and we'll call it a day. It's already 5 and we'll go in general and around 5 to 15, somewhere in that range. So So we'll just do one more. Any good ones that I really like? How about this one? So, oh, I did that one already. Sorry, just a second. Some of these are the same. This one. So the speed of sound. The speed of sound is 5,023 feet per second. In ocean water, whose temperature is 77 degrees Fahrenheit. Love that question, or that statement. So it says convert the speed, convert the speed of sound to miles per hour. I just wanted to mention this problem because it's just very odd, right? And it's odd because they give you unnecessary information. And so whenever you're reading, in general, those word problems, you should always say, what do I need this information, right? And so they tell you it's in ocean water, whose temperature is 77 degrees Fahrenheit. And you don't need that information at all. It's completely superfluous. Yeah, it's just, so, things like that, don't worry about this. If you're reading questions like on the homework or in future homeworks and you have things that don't make any sense, just if the information is not necessary, don't worry about it. Sometimes it's just unnecessary, like this. I don't need to know it's 77 degrees Fahrenheit. Basically, if you pick out the important bits, you'll be better off. So I need to know that the speed I want to start with is 5,023 feet per second. And I know I want to convert that to miles per hour. That's all you need. All right, so, kind of scribble out things that you think are necessary. And so let's do it. So 5,023 feet. And again, the word per, it's really the theme of the day. The word per means over one of whatever the other unit is. So over 1 second. And I want miles per, again, over 1 hour. So I want to convert this feet into miles and the seconds into hours. So feet in the bottom, miles in the top. And then we know that there's 5,280 feet in a mile. So the feet cancel. And then to get to hours, you can do it like we did before, where we know that there's 60 squared or 3,600 seconds in an hour. So I put seconds up in the top, hours in the bottom. Those cancel. And now I have my desired units. And as I said, there's 3,600 seconds in 1 hour. And so I just multiply that through, and that will give you the speed of sound in miles per hour. So I'll rewrite it. So 5,023 times 3,600 all over 5,280. And this is miles per hour, which is usually written like this, but again, it's just miles over hours. Right? And so as a number explicitly, I have 5,023 times 3,600 divided by 5,280. It's really fast. So that's quite large. 3,025 or 3,200 or 3,400. Sorry, 25. 3,425 miles per hour. It's like wildly fast. But if you look at this, right, it's going 5,023 feet per second. A foot is 5,280 feet. So it's going basically a mile per second. And so if I want it in hours, then it's going to be just slightly less than the number of seconds in an hour, because it's going just about 1 mile every second. And if there's 3,600 seconds in an hour, then it makes sense that it's going almost 3,600 miles per hour. Right? So you can also do things like that. If like this might not make sense in a normal problem, but in this kind of context, it makes perfect sense. So, any questions? Right. So I think I covered everything that was particularly odd on the homework. So you should be able to finish the homework. Again, I gave you like an extra week or something. Double check on my open math, but you should have a few more days at least to finish that. We're gonna start a new topic next class. We'll start talking about percentages. We're done with units for now. We'll talk about percentages and yeah, it'd be good. We'll talk about, rates. We talked about percentages initially, way back we did exponentials, but my internet's unstable. I don't know how that works. But we're gonna start talking about them more in depth now. So we'll do a lot more with like growth and finding like taxes and solving for what an initial value was for a purchase where you have like an 8% tax. All right. So I'll see you all Tuesday. Let me know if you have questions over the weekend. We can Zoom over the weekend if for some reason you have homework questions or just you need to talk about material or something. So just shoot me an email. All right. Toodaloo. Let's see, stop share.